Zinc concentrates are zinc ores that have been enriched after removal from the mine. They are delivered from all over the world in a granular bulk form. Enclosed conveyor belts transport the concentrates for temporary storage. Sulfuric acid is also shipped from the harbor. It is the main byproduct of the production of zinc. Zinc concentrates from various mines are temporarily stored. The crane picks up various types of concentrates, mixes them, and blends them in order to obtain the right mix, which makes for the specific needs of certain zinc refiners, ensuring the highest quality of refined zinc. The mixed concentrates are transported on conveyor belts to the roasters. In the roasting plant, the mix of zinc concentrates is introduced into fluidized bed furnaces. With the addition of air, the sulfur contained in the zinc concentrates is released and oxidized at about 1000 degrees Celsius to produce sulfur dioxide gas. This gas is then purified in several phases and transformed into sulfuric acid. Sulfuric acid is a key byproduct of the zinc production process, and it is an important base material for the chemical and pharmaceutical industries. The roasted zinc material is now mostly soluble in acid and is deposited towards the bottom of the roaster. Once cooled and ground, it is then pumped into the reservoir of the leaching plant. The roasted material from the mine is purified along with recycled material called a Welz oxide. The Welz oxide is an important raw material for making zinc. It is in the form of a powder produced from the recycling of zinc-coated steel. Both the roasted ore and the Welz oxide are purified in the leaching plant by dissolving in sulfuric acid. Any accompanying impurities are precipitated. This leach solution, free of solid matter, is then heated and purified in 3 phases prior to proceeding to the production of metallic zinc. Metallic zinc production is based on electrolysis. Lead and aluminum sheets are suspended in baths, which are filled with the zinc-containing leach solution or electrolyte. The sheets are connected in an electric circuit, where the lead sheet becomes the anode and the aluminum sheet becomes the cathode. The voltage drop across the anodes causes the zinc to deposit onto the aluminum sheets. The pure electrodeposited zinc is then peeled off the aluminum plates, washed, and transported to the melting furnace in the casting plant. The aluminum sheets will be put back in the electrolytic baths and reused to deposit more zinc from fresh zinc-containing electrolyte. The electrodeposited zinc from the electrolysis step is melted at over 420 degrees Celsius in induction furnaces and cast into slabs or jumbos weighing from 1 to 6 tons or into special shapes, depending on its use and the needs of the customer. In some cases, additions of small amounts of aluminum or other metals are added to meet customer requirements. Strict quality controls are followed during the casting process, including the regulation of returning scrap from the casting process to the melting furnace.